Okay, in this fourth tutorial, we're going to go over the respiratory cycle. So this graph here, it looks complicated when you first look at it, but you just need to remember that it's measuring the amount of air coming into and out of your lungs. When a line goes up, it means that air is coming into your lungs because there is an increase in volume. When the line moves down, it means you're exhaling and you're pushing air out of your lungs, therefore your volume is decreasing within your lung. Now, let's say we're just breathing normally. You're just sitting here, inhaling, exhaling. That's normal. It goes in and out, and the amount that you breathe in is the same that you breathe out. Now, if we were to represent that on a graph, it would look like this. Inhale, exhale, inhale, exhale. So just in and out normally. And then if you would come here, and then all of a sudden you need more air, you inhale as much as you can. That goes all the way up because you're inhaling as much air as you can. Now, when you let that air back out, you exhale and you come back down to this normal line. And say you want to get all of the air out of your lungs now. You go and you push it all out. But you couldn't get all the way down to 0. And we'll talk about that when we come to these volumes. So when you inhale, you reach a point, and then you go back up, and say you just go back to normal breathing, aka these normal lines. Let's break these down. This normal breathing here, that's called tidal volume. We'll just do the shorthand version, tidal volume. And it's called that because it kind of looks like a wave. It's just tidal, it's normal, in and out. Now this part here, if you want to track it over, anything above this tidal volume is called your inspiratory reserve volume. So it's the amount of air that you are able to inhale. So it's everything. So imagine your lung was just a little bit open, and like open shut. Then at a certain point it could stretch, and the biggest stretch that it could achieve would be this inspiratory reserve volume. Now, after that, you breathe all your air out, and at the bottom of this tidal volume, all the way down to all the air that you can get out of your lungs, so you squeeze it all out, you get to this expiratory reserve volume. So you can see that these are both reserve volumes because it's the amount that you have left in the tank. So it's the amount of air that you're able to push out when you need to be able to breathe faster with more volume. Then finally, you have this residual volume. Residual means leftovers. So it's the amount of air left over in your lung after you've tried to push out everything. It's all that's left over. And that's important because if you weren't to have that air in there, your lung would collapse. So you need that air just to keep your lung inflated a little bit so that you can breathe easy. Now, we know that volumes are things that are measured because we can see it on the graph. If you were to look at the graph, you could just draw the dots along and you can see how far that is, how far that is. So these are just measurements, whereas capacities, the things over here, you have to add 2 volumes together, or 2 or more volumes together, depending on what capacity you're looking for. So now I'll quickly go over to the capacity side and explain which ones there are. Now that we're over here, there is this line here that is from this middle line all the way up. And you call that your inspiratory capacity. Because it's a capacity, it's made up of this tidal volume plus this inspiratory reserve volume. So basically, it's this line here where it goes the total amount of positive that you're able to achieve. I just got some pens to make it easier to see. So inspiratory capacity is basically from this line all the way up to this top. And that's this portion here. Okay, now functional residual capacity is basically whatever's left over from this inspiratory capacity. So it's this expiratory reserve volume plus this residual volume. So it's basically what would happen if you were having this normal tidal volume and then your lungs collapsed? How much air would be let out? So it's all of this portion here. So that plus that. Next, we have this line here, which is the vital capacity. Now, this vital capacity is basically all of the air that you're able to breathe. So it would include everything from the top all the way to the bottom of this line. So that includes the inspiratory reserve volume, the tidal volume, and this expiratory reserve volume. So that's 3 different volumes to make up this vital capacity. Then finally, you have the basically most simple one, and that's the total lung capacity. That's all of the air within the lung. That includes this residual volume, the expiratory reserve volume, the tidal volume, and the inspiratory reserve volume. So if we were to put numbers, this one has 4 volumes to make up this capacity. This vital capacity has 3 volumes to make it up, and then these 2 have 2. And that's it with the capacities. Now we'll do a quick recap of the respiratory cycle. When you're breathing in and out, normally just tidal volume, that's this here, up and down normally, tidal volume. Now if you were to breathe in, so you breathe in normally, and then you breathe in even more, all the way up, that's your inspiratory reserve volume. Now if you're just to exhale all of that, and then you get to this bottom of your normal tidal volume, and you breathe out all that you can, so you reach a point where you can't go anymore, that's your expiratory reserve volume. And that anything else that's left in your lung after you've tried to push out all the air is called your residual volume, and that's what allows the lungs to stay inflated. Now we have our capacities, which are the sums of multiple volumes. Inspiratory capacity is basically all of the air that you're able to inspire. Then functional residual capacity is all the air that you're able to expire if you were to like pop your lung and squeeze it out. So that's from the bottom of your tidal volume all the way down to 0. Then you have your vital capacity, which is all of the air that you're able to breathe. So from the top breath all the way out to all the way out. That's your vital capacity. So it's made up of your inspiratory reserve volume, tidal volume, and your expiratory reserve volume. And then your total lung capacity is all of the air in your lung. So all the way in to all the way out, and then to get rid of all of residual volume. So all the way down to 0. That's the end of the respiratory cycle.